What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 11, Chapter Review Exercises. Let's do it. So for this one, we're meant to determine whether the ordered pair is a solution to the system. And the way I'm going to do that is just going to straight plug and chug, right? This is my x value, this is my y value. So I plug it in there. I get 3 times -1 minus 1, which is y, is that equal to 4? And we get -3 minus 1, and that's -4. It does not equal 4. Immediately, I can say, since it has to satisfy both equations, so this is not a solution, we'll say no, boom, done. So for this one, we're going to use a little substitution, as it says, to solve the equation. So substitution, I need to isolate one of the variables. So let's look at this top equation. I'm going to divide everything by 5 first. So then I get 2x plus 1y equals -1. Again, divided each of these by 5. Now I got y in a position where I can isolate it easily by subtracting 2x from both sides. So now I got an expression for y in terms of x. Now I can take this and plug it in down here. So I have 3x minus 2 times y, and I'm going to replace y with -2x minus 1, and this equals -12. Now we're going to distribute, and I'm going to solve for x. So I got 3x plus 4x. Don't forget that's a -2 times -2. And then plus 2 equals -12. 3 plus 4 is 7x. And then let's simultaneously subtract 2 from both sides. -12 minus 2 is -14. Divide by 7, and we get x equals -2. Now to figure out what y is, plug it back in here. -2 times -2 is 4. 4 minus 1 is 3. So y equals 3. So if we're going to write this in coordinate format, we'll say -2 for x, 3 for y. That's how you do it. Done. To do this one with substitution, again, we need to isolate one of the variables. I'm going to look at this second equation. I think it's going to be easier because if we divide everything by 4, I get 1x plus 2y equals 2. Then I can quickly subtract 2y from both sides, and I get -2y plus 2 equals x. Now I can take this and plug it in for x for that top equation, right? So I got 5 times, instead of x, I'm replacing it with -2y plus 2. And then we still got the 6y, and that equals 14. So we're going to be solving for y here. So let's distribute. We got -10y plus 10 plus 6y equals 14. These guys combine. -10 plus 6 is -4y plus 10 equals 14. Subtract 10 from both sides. -4y equals 4. Last but not least, divide both sides by -4y equals -1. So now we have our value for y. Let's take this and plug it in over here. -2 times -1 is 2 plus 2, which means x equals 4. So there we have it in coordinate form. We got 4 for x, -1 for y. That's how you do it. Done. For this one, we're using addition, aka elimination, as I like to call it, which is my favorite method. And to do that, what I'm going to do is I'm going to choose one or both of the equations to multiply by something so we can line them up and then we can eliminate one of the variables. So I'm going to multiply the top equation by -3, just looking at the x's, because watch what happens. I get -9x. So when I add these together, now the x's will cancel out. Then I go to -3 times 4, which is -12y, and then -3 times 2, which equals -6. But something interesting happens. When I add these together with my intent of eliminating x, which does work, the y's also cancel out. 12y plus -12y, that's also 0. So now we have 0 equals, and then we do 3 plus -6, which is -3. So we're left with a really bizarre equation, which isn't true, obviously, right? 0 does not equal -3. So we get into this situation, we say this is a no solution situation. The reason why is if you graph these two equations in Desmos, you'd see that they're parallel. And again, when we're looking for a solution to a linear system, we're looking for the intersection. Parallel lines never intersect, no solution, boom, done. So for this one, we have a cost function right here, and then we have a revenue function right here. And we want to know what's the break-even point. And what is break-even? That's the point where your cost is exactly equal to your revenue. So guess what I'm going to do? I'm going to set these two guys equal to each other. 150x plus 15,000 equal to 200x, okay? Now I'm just going to solve for x. So we're going to subtract 150x from both sides like so, boom, boom. And we got 15,000 equals 50x. Divide both sides by 50, right, to isolate x. And let's see, 1, 0 cancels out. 1,500 divided by 5 is 300. So that means The break-even point occurs when, let's see, does it even say what X stands for? I guess X is, I assume it's the number of units produced. So the break-even point occurs when we make 300 units, and 300 times 150 is 45,000 plus 15,000, which is 60,000. So the break-even point is when we're producing, I guess, 300 units, or X is 300 and the Y value is 60,000, meaning the revenue and the cost will equal 60,000 at that point. That's how you do it. Done. So for these triple systems, what I like to do is I like to kind of separate the equations normally up into two groups. But here, we kind of have a special situation because I have two equations right at the top that only use X and Y. And that's really cool because I can use those two equations right off the bat individually to solve for X and then plug it in at the end to solve for Z. So what I'm going to do here is I'm going to start off by, I'm going to divide the top one by 0.5, okay? Because that's going to get a single X and Y. So that's going to be 1X minus 1Y, and then 10 divided by 0.5 is like multiplying it by 2, so that's 20. So then with the second equation, I'm going to divide by negative 0.2, and that's going to give me 1Y, that's going to give me negative X, and that's going to equal negative 20, okay? And what you can see here is we got something peculiar right off the bat, which I didn't anticipate. So now and if I rearrange this, right, it's y minus x, which is the same as negative x plus y. And if you look at these two equations, what happens when we add them together? Boom, boom, boom. We get 0 equals 0. What does that mean? That means that those two lines are the exact same, okay? This is an infinite solution situation. And what that also means then is there's a constant relationship such that x minus y is equal to 20, meaning y is equal to x minus 20, okay? So we have an interesting situation now. We know we have infinite solutions, and we know that we have this relationship where whatever x is, y has to be x minus 20. And then if we want to know what z is in terms of x, we can take this final equation, we can divide everything by 0.1, and we get x plus z equals 20, which means z equals 20 minus x. So then we can put in 20 minus x like so. So anyways, that's how you do it. There's infinite solutions. This gives the nature of the solutions, right? Whatever x is, y would be 20 less, and then z would be 20 minus whatever x is. So that is how you do it. Done. So for this one, right off the bat, again, we're going to separate into kind of like two groups, okay? That's what I kind of like to do. We're going to start with the top two equations. So I get x plus y plus z equals 1. And then for the bottom one, I can leave it as is, but since I know I'm going to like to probably do elimination, try and eliminate one of the variables, I'm going to divide the entire bottom one by negative 2. So I get negative x minus y minus z equals negative 1/2, okay? Now, my plan was originally to get rid of one variable, ideally maybe z, because there's no z down here. But look what happens when I do that. That goes away, that goes away, that goes away. They all zero out, and I get 0 equals 1/2. Now, this is not a true equation. We get something that is patently false, which means since 0 does not equal 1/2, we can stop right here, and we know that this is a no solution situation, and that's how you do it. Done. So for this one, I am going to group these two together, and we're going to aim to, in both of these groupings, eliminate the same variable. Let's go with z, and it's going to be pretty easy. So what I'm going to do for the top equation, I'm going to say 3. Actually, wait. No, I'm going to multiply the top equation by 2, because then it's going to be negative 2z. So I'm going to multiply by 2. I got 6x plus 4y minus 2z is equal to negative 20. And then the second equation, I'm going to leave it as is, just like so, okay? And we're going to add these two together. We get negative 13 over here. The z's are going to cancel out, which is beautiful. That's what I want. 4y minus y is 3y, and then 6x plus x is 7x, okay? So now we have an x and y equation. We need to do the same with these two. So again, eliminating z, I'm going to keep the second equation as is, just like that. And then this one I'm going to multiply by negative 2. So watch what happens. I get positive 2x minus 6y minus 2z. That's the whole reason why we did it. And then we get positive 4. And now when I add these together, goodbye z's. X plus 2x is 3x. Negative y plus negative 6y is negative 7y. And then we've got 11 over here. So check this out. I got this equation and this equation. And now we need to combine these two in a way to isolate for x and or y. So let's again go to elimination. Let's eliminate the x's. I'm going to multiply this equation by 3. So we get 21x plus 9y equals negative 39. I'm going to multiply this one by negative 7. Then we get negative 21x. Negative 7 times negative 7 is 49. Y equals negative 77, okay? And then when we add these together, goodbye x's, 9 plus 49 is 58y. And then we got, let's see, 40 plus 77 would be 117, but it's 39, so it's 116, right? Negative 116. This is beautiful because when we divide by 58 for y, we get negative 2, okay? So we got negative 2 for y. Now we're going to plug this back in here, how about, to get x. So that's 7x, negative 2 times 3 is negative 6 equals negative 13. Add 6 to both sides. 7x, sorry, we're running out of room. 7x equals negative 7, and that means x equals negative 1. Last but not least, we can solve for z. Let's plug into, let's do the top one. So 3 times, and we can do any of them, it doesn't matter. 3 times negative 1 is negative 3. 2 times negative 2 is negative 4, so minus 4. And then minus z equals negative 10. That is negative 7. We add 7 to both sides. Negative z equals negative 10 plus 7, which is negative 3, which means z equals positive 3. All right? So in coordinate format, we say negative 1, negative 2, 3. That's how you do it. Done. So for this one, we're going to start by grouping, and then we're going to use some nice elimination here. So with the top equation, top two, I've got a really nice setup, right? I can easily eliminate the x's by negating the top equation. So I'll just multiply it by negative 1. So negative 2x plus 3y minus z equals 0. Leave the second equation as is, right? Like so. And then we're going to add them together. These guys are going to cancel. 3 plus 4 is 7y. Negative z plus negative 3z is negative 4z. And all of this equals 0. Okay, so now we've eliminated x. We need to do the same with the bottom two. So I'm going to multiply the bottom one this time, or the middle one, by negative 3. So we got negative 6x minus 12y plus 9z is equal to 0. And then this stays as is, right? 6x minus 2y minus z equals 0. So then we add these together. Goodbye. Negative 12 plus negative 2 is negative 14y. 9z minus z is 8z, and then we equal to 0. Now we're going to add these two together to isolate. So, and basically eliminate. So let's eliminate the y. So I'm going to multiply the top one, this one, by 2, and I get 14y minus 8z equals 0. But then look at this. I got negative 14y plus 8z equals 0. And we add these together. Goodbye, goodbye. And we get 0 equals 0. So what does that mean? It means we have an infinite solutions situation. But we're gonna see the relationship in terms of, everything related to x. So first of all, from this equation, I can see that 7y, if I add 4z to the other side, equals 4z. So I've got this relationship between z and y. If I divide both sides by 4, I get z equals 7/4 y. Okay, so what can I do with that? I can take this back to these equations and plug and chug. So I'm going to take this first equation because I want to get everything in terms of x. So I can say 2x minus 3y, and then I can replace z with 7/4 y, plus 7/4 y, and this all equals 0. Then I can get a nice common denominator. Negative 3 is the same as negative 12 over 4, right? 3 over 1 multiplied by 4 and 4, so we get negative 12 over 4. So negative 12 plus 7 is negative 5, so I got minus 5 over 4y equals 0. And then we can get the 5/4 y on the other side. 2x equals positive 5/4 y. And then multiply both sides by the reciprocal of 5/4, which is 4/5. And then 4/5 times 2, that goes away, is going to be 8 over 5. So y, here, let's write over here, y equals 8 over 5x. And then if I want to know what z is in terms of x, take this value right here, right? And I plug it in for y over here. So then I got 7 over 4 times 8 over 5x is what equals z. And this becomes 56 over 20. Or if we simplify, that becomes 1, that becomes 2, and we get 14 over 5x. All right, now to put the whole thing into coordinate format, let's make a little bit room. We've got x is x. We said y is 8/5 x. And last but not least, we said z is 14 over 5x. And that is how you do it. Done. So for this one, we got 3 odd numbers that sum up to 61. So let's write that out. And we're going to make these numbers x, y, and z. Again, that's just arbitrary, right? So the first one is they add up to 61. Okay, great. And then it says the smaller one, let's call x the smaller one. The smaller one is 1/3 the larger. Okay, so let's say the larger is z. Let's just go with that. And then it says, and the middle number is 16 less than the larger. Okay, so now we got some interesting equations to start with. And by the way, I can immediately start using substitution by taking this nice little equivalency, meaning x is equal to 1/3 z, and I can plug this in right here for x. And what that's going to do is give me 2 variables, z and y only. So now I have 1/3 z plus y plus z is equal to 61. And that's great because here I have a y and a z situation. So guess what? Now I can substitute this in for y. And now I have a nice equation with just z. I have 1/3 z plus, replace y with z minus 16, like so. And then I have plus z is equal to 61. So now we begin by solving for z. So I got 1/3 z plus z. That's 2z, which is 6/3. So that becomes 7/3 z, okay? Minus 16 equals 61. I'm going to add 16 to both sides, so 7/3 z equals, what is that, 77, right? And then to isolate, I'm going to multiply by the reciprocal of 7/3, which is 3/7. So z equals, and then we got 3/7, right? Times 77, divide by 7, that's 11, times 3 is 33. So this is a good sign because z, it does say they're odd numbers. 33 is an odd number, so now we know z. Okay, now let's get x and y. So I know that y is z minus 16. So 33 minus 16, that's 17. And again, that's great because that's another odd number. And that's what it said, 3 odd numbers. And last but not least, we're taking 1/3 of z, 1/3 of 33, which gives us x. 1/3 of 33 is 11. So there we go. We solved it. We've got 11, 17, and 33 for the 3 odd numbers. They do add up to 61. That's how you do it. Done. Okay, so for these ones, we're solving nonlinear systems of equations. And for this one, it's primed for substitution. I'm going to roll right with it because I know that y equals this and y equals this. So guess what? They both equal y. I can just plop this in for the y up there and set them equal to each other. So we got 5x minus 13 is equal to x squared minus 7. This is a nice quadratic. Let's bring everything to the right-hand side. X squared, we're going to subtract 5x from both sides, so that brings that over there. We're going to add 13 to both sides. 13 plus negative 7 is 6. And now we got everything equal to 0. And if this is factorable, we're in great shape because we can immediately use the 0 product rule. And this is factorable, right? What multiplies to positive 6 adds to negative 5. That's negative 2 and negative 3, which means we got 2 solutions. We got x equals 2 and x equals 3. Okay, so and these are the x values, 2 and 3. So ideally, they're going to correspond with y values, right? So there's going to be 2 points of intersection. Now we plug into either equation. Let's plug into the bottom just because it's a little easier, and we'll get our answer. So 2 times 5 is 10 minus 13 is negative 3. 3 times 5 is 15 minus 13 is 2. And we'll just verify it works in the top equation as well. So when I plug in 2, I get 4 minus 7 is negative 3. When I plug in 3, I get 9 minus 7, which is 2. Those are your 2 solutions. Done. So for this one, once again, I'm going to use substitution, right? I see that y equals this, so let's pop that in for y up top. So then we got x squared plus, I'm replacing y with x minus 8 squared, and this all equals 16. All right, let's FOIL this out now. So again, remember, that's x minus 8 times x minus 8 because it's squared. So as we FOIL this out, we get in x squared, and then we get negative 8x and negative 8x, which is negative 16x, and then negative 8 times negative 8 is 64. And this all equals 16. So once again, we're going to use the 0 product rule because we got a nice quadratic. So we got 2x squared minus 16x, and then we're going to subtract 16 from both sides. We set everything equal to 0. 64 minus 16 is 48. And then we're going to divide everything by 2. We got x squared minus 8x plus 24 is equal to 0. Now let's see if this is factorable, okay? So what two numbers theoretically multiply to positive 24 and add to negative 8? So the only thing I can think of is like negative 6 and 4, negative 8, negative 3. So it actually seems like it's not factorable. So we're going to have to back out of this and go to our good old-fashioned quadratic formula, which is negative b. So we got a, b, and c. These are those coefficients and that constant. So negative b plus or minus the square root of b squared, which is negative 8 squared, 64, minus 4 times a, which is that invisible 1, times c, which is 24, all over 2 times a, which is 2. Now, what we see here is 4 times 24 is 96. Well, guess what? 64 minus 96, that gives us a negative answer. So when we have a negative under the radical in the quadratic, it means no real solution. So we'll just roll with no solution, no intersection. That's how you do it. Done. So for this one, we're going to use a little substitution. I'm going to isolate the y here. I'm going to add x squared to the other side. And then this can now plug in for y. So we got x squared plus 3. And that whole thing squared, right? And this whole thing equals 4. Okay. So now we're going to foil that out. So that's, again, x squared plus 3 times itself, just so we can see what's happening here. And then we get x squared plus x to the 4th, right? Plus 3x squared, that's 6x squared. And then plus 9 equals 4. And then we got x to the 4th plus 7x squared, right? X to the 4th, these make 7x squared. And then we're going to simultaneously subtract 4 from both sides, which makes that 5 is equal to 0. Now, this is not a quadratic, right? It's to the 4th power, but we can still kind of solve it like a quadratic with a little substitution, right? So I can say, let's make another variable where z equals x squared. And we can, but this is not factorable, by the way. We can plug in z for x squared. So now we got z squared plus 7z plus 5 is equal to 0. All right, now we can use the quadratic formula to see what we can get here, if we can get a solution. So we got, again, a, b, and c. We got negative b, which is negative 7, plus or minus the square root of b squared, 7 squared, and then we get minus 4a, which is 1, and then c, which is 5, all over 2a, which is 2 times 1, which is 2, okay? And that's 49 minus 20, which is 29. So we got negative 7 plus or minus rad 29 over 2. Now, again, this is what z equals. So x squared equals that, right? So let's make a little bit of room up here. So we say x squared equals negative 7, all this stuff, right? So just so you can see, square root of 29, it's a little bit bigger than square root of 25. Square root of 25 is 5. Square root of 36 is 6. Bottom line is, whether this is a plus or a minus, this is going to be negative, okay? And you can check that in a calculator. So the thing is, if you're taking the square root of a negative to actually get x, well, you can't do that, right? Square root of I mean, you can do that, you get an imaginary number, but you don't get a real number, which means that since this goes into imaginary numbers, there is no real solution. That's how you do it. Done. So for this one, we're meant to graph this inequality. And before I do that, what I'm going to do is I'm going to get it into, because this is an ellipse, so I'm going to get into that nice format where this is 1 over here. So we're going to divide everything by 4. So this becomes x squared over 16 plus y squared over 4 is less than 1, okay? And now what this does is this gives us my kind of horizontal axis and my vertical axis. And we also know that since there's no x plus this, y minus this, it's centered at the origin. So now that we know that since we've got 16 under x squared, that's really going 4 left and 4 right, okay? This is going to be called the major axis. So we know we're going out here and here. And then y, we have a above 4, which is 2 squared, right? So that means a minor axis of going up 2 and down 2. And this is our ellipse. Now, I'm making it dotted because it's an inequality and it says less than, not less than or equal to. The last part is the shading. And since it says less than, okay, that means we shade the interior of this ellipse. And that's it. That's how you do it. Done. All right, so for this one, we're going to graph this system of inequalities. The first thing I'm going to do for the top equation is I'm going to get these x's together, right? I'm going to consolidate like terms. So we got x squared minus 6x, and then we got plus y squared, and this is less than 4. So this again looks like an ellipse. It's just not in that correct standard form. So what I'm going to do so we can graph this properly is I'm going to complete the square, right? I'm going to take half of -6, which is -3, and I'm going to square it. And I'm going to add that to both sides like so, okay? What happens here is we've created a nice perfect square which factors to x minus 3 squared, right? If I FOIL that out, I get x squared minus 6x plus 9. And this y squared, we can kind of just leave it as y minus 0 squared. Now that's a formality. I don't need to do that. I can leave it as y squared, but I'm going to explain why in a second, why that's going to be helpful for the graph. And then this is all less than 13. And now that I have it in this form, I can see that actually this is a circle, okay? This is a circle with a center at 3, 0, and a radius that is the square root of 13. So that's pretty cool. This guy's already in that nice slope-intercept form as a linear equation. So that's going to be pretty easy to graph. So now let's pull up a graph. So we got 3, 0, there's the center. And the square root of 13 is about 3.5. Let's just say approximately. And once again, this is a less than situation, so we're going to make this dotted. And because it's less than, the shaded part is the interior, but it's a system, so we have to look at the overlapping of the shaded. Now let's graph this guy. So we have a y-intercept of 4 and then a slope of -1. Again, it's less than, so it's a dotted line. And when we say less than, it means it's shaded below. And we're shading on the inside of the circle. So the overlap is going to be all of this region, the inside, but also what is simultaneously below this line. And that is how you do it. Done. For this one, we're going to decompose the fractions. And before we start decomposing, what I'm going to do is I'm going to factor the denominator. So we got -2x plus 6 is equal to x plus 1 and x plus 2. So how did I know it's x plus 1, x plus 2? What multiplies to 2 and adds to 3? Positive 1, positive 2. And then as we decompose the fraction, since we got a nice linear expression on top, we got a over x plus 1 plus b over x plus 2. Now, once we have it in this format, we're going to multiply both sides by this denominator, okay? So I'm going to get rid of everything on the left side in the denominator. We're just going to have -2x plus 6. Now, on the right-hand side, when we multiply by this denominator, okay, these are going to cancel out here, and that's going to leave me with a times x plus 2. And when I multiply it against this guy, right, these are going to cancel out the x plus 2's, and I'm going to be left with b times x plus 1. Okay, now we're going to distribute, and we have -2x plus 6 equals ax plus 2a plus bx plus b. All right, so now let's match up the matching parts, right? I know that ax and bx are going to combine to give us -2x. It has to be, because those are the only terms with x's. So that means a plus b equals -2. I also know that 2a plus b must equal 6, right? These are all the constants, so they must be equal since the two sides are equal. So we can say then that 2a plus b equals 6. Guess what? We have a system of equations, 2 variables, 2 equations. We're ready to do this. So now I'm going to solve using elimination. Negate, negate, negate. Let's add these two together, and the b's cancel out. -a plus 2a is a. 2 plus 6 equals 8. So a equals 8. And then I know that coming back to our original equation, let's just get rid of the negatives, make it easier. So since I know that a plus b equals -2, if a is 8, what plus 8 gives us -2? That's -10. So we got b is -10. So now coming back to this original expression, we can get the partial fraction decomposition as a, which is 8, over x plus 1 plus b, which is -10. I'll just say -10 over x plus 2. And that is how you do it. Done. And just FYI, I think they made a little mistake in the back of the book. Those are not the correct partial fractions, but anyways, that's how you do it. So for this one, once again, we got a nice linear factor on the top, and we're going to factor that on the bottom. So we have 7x plus 20 over, and this happens to be a perfect square trinomial. It's actually x plus 5 squared. And then now when we have a repeated factor on the bottom, it's a little bit different than when we just had two different factors. So it's going to be a over x plus 5, and then the b is going to be over x plus 5 squared. Okay, great. Now we're going to multiply both sides by that denominator of x plus 5 squared. Obviously, on the left side, these are going to cancel out, and we're just left with 7x plus 20. When we multiply against the a, one of these are going to cancel out, and then we're left with a times a remaining x plus 5. And then we multiply against the b, these are going to completely cancel out, and we're just left with b, like so. All right, now we're going to simplify on the right-hand side. We've got equal to ax plus distribute, right? Boom, boom, 5a plus b. All right, now since this is the only term with an x, we know that a must equal 7. And then we know that 5a plus b has to equal 20. Since a is 7, 5a is 35, plus b equals 20, which means b must equal, if I subtract 35 from both sides, negative 15. All right, so our final answer is, now we come back here and we replace the a and the b with our values. So we got 7 over x plus 5, and then we got minus 15 over x plus 5 squared. And that is how you do it. Done. So for this one, we're going to start out by seeing if we can factor this guy, which we can because it's a difference of cubes. And the way it factors, and I like to remember a little thing called same, different, plus, is, you know, if a difference of cubes, we put the cube root of that and that right here, which is x, and 125 is 5 right here. Then we got x squared here, then we got x times 5 here, and then we got 5 squared, which is 25 here. Okay. And what we have is we have a non-repeated irreducible quadratic factor, which means we're going to have a over the x minus 5. And then for the next part, we're going to have linear on top of that quadratic. So we got bx plus c over all of this, x squared plus 5x plus 25. Okay, now we're going to follow those same steps. We're going to multiply everything by this denominator, right? And what's going to happen on the left side is this is going to completely cancel out. So we're just left with that numerator. And then on the right-hand side, when we multiply this guy, these are going to cancel, and we're left with a times x squared plus 5x plus 25. And then when we multiply against this guy, these are going to cancel, and then we're left with bx plus c times x minus 5. Okay, there we go. Now let's simplify and solve for a, b, and c. So next I'm going to distribute, and we're also going to FOIL this guy. Boom, 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 boom. And we got ax squared plus a5x plus 25a, and then we've got plus bx squared. Okay, then we got minus 5bx, and then we got plus cx, and then minus 5c. Okay, now let's take a look at everything. I see some interesting things right off the bat. I see the only constants are here and here. And that's pretty cool because that's going to equal 70. So 25a minus 5c equals 70. Okay, so there's our first equation. I also see an x here, here, and here. And so that means 5a, I wrote a5, but I'm going to write it as 5a, same thing, minus 5b plus c, right? I didn't miss any other x's. Those are all going to add up to this, which is 36, okay? And then last but not least, we've got these guys, right? The only two x squared. So, and they have to add up to -1. So that means a plus b equals -1, okay? We got 3 variables, 3 equations. Let's do this. So first things first, you know what I'd love to do is I'd love to get rid of this c, and then I'd have a nice 2 equations with a and b only. Okay, so what I'm going to do is I'm going to take this equation, I'm going to add 5c to the right side, I'm going to simultaneously subtract 70 from the right side, and then we got this, divide both sides by 5, and we got c equals 5a minus 70 divided by 5 is 14. Okay, now what we're going to do is we're going to take this and we're going to plug it in for c here. And then we got 5a minus 5b plus, instead of c, I got 5a minus 14 equals 36. Okay, making a little bit more room, combining like terms, I got 10. Making a little bit more room, combining like terms, I got 10a minus 5b. And then let's add 14 to the other side equals 50. And then here I have a plus b equals -1. Actually, before we even combine these, I'm going to divide this by 5. And I got 2a minus b equals 10. Now let's write this right below, right? A plus b equals -1. And now it's perfectly set up for addition / elimination, right? Just add these together. Goodbye, b's. I got 3a equals 9, which means a equals 3. Okay, so there's my first value. Then I can plug in 3 here. That's 3 times 5 is 15 minus 14 is 1, so c is 1. And then now we just got to figure out what b is. And since I know a plus b is -1, 3 plus -4 would be -1, so b is -4. Now we can take these values, -4, 1, 3, and we got b -4, c equals 1, a equals 3, and we can just replace these guys with those values. So let's make some room. So we got 3 over x minus 5 plus, and then b is -4x, and c is +1 over x squared plus 5x plus 25. And that is how you do it. Done. So for this one, we have a repeated quadratic factor. And the way we set this up is as follows. We've got linear factors on top, right? So ax plus b over just it as is, right? X squared minus 2 plus, and then we've got cx plus d over that same thing, but the entire thing, right? X squared minus 2 squared. Okay, so this is our starting point. Now, once again, we're going to multiply both sides by that denominator, x squared minus 2 squared. Okay, so on the left side here, these are going to cancel out, right? And we got just that numerator. Then over here, when I multiply against this term, I got this canceling out with that, and then I'm left with ax plus b times x squared minus 2. And then when I multiply against this guy, these denominators completely cancel out, and I'm just left with cx plus d. Okay, now we got our equation. Let's make some more room. We got a lot of work to do. Now we're going to FOIL this out to simplify. So we go boom, 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 boom. And we got ax cubed minus 2ax plus bx squared minus 2b, and then we got plus cx plus d. So since I've only got one x cubed term, I can see that these must match up, which means a must equal 1. Okay, so that's pretty cool. And by the way, I think I dropped that squared over there, but it is supposed to be 4x squared. And the good news about that is this is the only squared term here, which means those have to match up. That means b must equal -4. Now we get to the x, right? I see I've got plus 3x here. So 3 is going to equal, what do we have for the x terms here? We have -2 and we have c. So that means -2 plus c must equal 3, which means c must equal 5. And last but not least, we got this constant over here, which is 11, and 11 equals -2b plus d, right? These are the only constants left. And we already know that b is equal to -4. So -2 times -4 is +8. So that means 11 equals 8 plus d, which means d equals 3. So now that we got a, b, c, and d, let's rewrite these with those proper values. So we got a, which is 1, so that's x, and then b is -4. So x minus 4 over x squared minus 2 plus, and then c is 5, so that's 5x plus d, which is 3 over x squared minus 2 squared. And that is how you do it. Done. So for this one, we are going to carry out this operation, which is multiplying a times -4. And that's a scalar operation, meaning what you're doing is you're literally just multiplying every value by that scalar, by -4. So the new matrix is going to be -4 times 4, which is -16. Then we got +8. -4 times 1 is -4, and -12. That's how you do it. Done. So for this one, we are adding b and c. But here's the thing. When we're adding or subtracting matrices, they have to have the exact same dimensions. And you notice this is 3 columns, 2 rows. This is 3 rows, 2 columns. So this does not work. This would be undefined. We're not able to carry this out. That's how you do it. Done. So for 43, we're doing matrix multiplication. We're doing this times this. And that order matters because here's the dealio. For whatever is the first matrix, which in this case is B, the number of columns of the first matrix must equal the number of rows in the second matrix when we're multiplying. Since that is not the case, since there are 3 columns and only 2 rows for A, this operation, we can't do it. Therefore, this is undefined, and that's it. That's how you do it. Done. So for this question, we're multiplying C times B, so let's set it up here. And as we can see, we've got 2 columns here, we've got 2 rows here. Those match, and those need to match in order to multiply, so that means this is indeed doable. Now let's move it down here and let's make some room. And the other thing that's good to remember is that, to get the final dimensions of the final matrix, as the product matrix, it's going to have the same number of rows here and columns here, right? So it's flip-flop. So we know we're going to end up with a nice 3 by 3 matrix. Let's make a lot of room here. And we're going to do some nice color coding. Okay, here we go. So first, we're going to kind of go down the line. We're going to go this times this plus this times this. And that's 36 plus 77. Then we go down to the next values. Then that times that plus that times that. That is 42 plus negative 14. Then we go this times this plus this times this. That is negative 18 plus 28. All right, so there's my first row. Now let's move along. So now we go start this guy multiplied all the way down the line again. So we go 11 times 6 plus negative 2 times 11. That is 66 plus negative 22. Then we go this times this plus this times this. That is 77 plus 4, right? Negative 2 times negative 2 is 4. And then we go this times this plus this times this. That is negative 33 minus 12 or plus negative 12. Now we're on the last row. Now we do 14 times 6 plus 0 times 11. That is simply 84 plus 0. Next we do this times this plus this times this. 7 times 14 is 98. And again, we have 0, so it's just going to be plus 0. And last but not least, we got 14 times negative 3 plus 0 times 4. 14 times negative 3 is negative 42, and then it's plus 0. Now, as we simply consolidate and simplify everything, 36 plus 77, that's 113. Here we have 42 minus 14 is 28. Negative 18 plus 28 is 10. 66 minus 22, that's 44. 77 plus 4 is 81. Negative 33 minus 12 is negative 45. Then we have 84, 98, and negative 42. And that is how you do it. Done. So for this one, we're multiplying E against D. And since the number of columns here equals the number of rows here, we know that this is doable, so let's write it out. So here we go, and they're both 3 by 3, and that means the resulting matrix is also going to be 3 by 3, so we'll just make some good room here. We're going to do a little bit of color coding to keep it nice and organized, and let's go. We go across the columns as we go down the rows. So here we go. This times this plus this times this plus this times this. So that's 7 minus 140 plus 6. Next we go this times this plus this times this plus this times this. Okay, so that is negative 28 minus 70 plus 24. And finally we go this times this plus this times this plus this times this. Okay, that is 63 plus 98 plus 15. All right, first row is done. Now we move along to the second row, and then we kind of repeat multiplying the first, second, and third column in that order. So we go this times this plus this times this plus this times this. So that is 2 minus 10 plus 6. Next, we have this times this plus this times this plus this times this. So that is negative 8 minus 5 plus 24. And then we go this times this plus this times this plus this times this. Or that plus that times that, sorry. And then we got 18 plus 7. 3 times 5 is 15. All right. Moving on to the final row. Now we got this times that plus this times that plus this times that. That's going to be 0 plus 10 plus 18, and then we go to the next one, next color. We go this times this, plus this times this, plus this times this. So 0 times -4 is 0. 1 times 5 is 5, and 9 times 8 is 72. All right, now we're on the final one. Let's go this color. We go this times this, plus this times this, plus this times this. So that's again starting with a 0, and then we have -7 plus 45. There we go. All right, let's simplify. So 7 minus 140 is -133. That would be -127. This one is -28 minus 70 is -98. Plus 24 is -74. These are all positive. 63 plus 15 is 78 plus 98. That's 160, 176. Then we got 2 minus 10, which is -8, plus 6 is -2. -8 minus 5 is -13, plus 24 is 11. 18 plus 7 is 25, plus 15 is 40. And then 0 plus 10 plus 18 is 28. 0 plus 5 plus 72 is 77. 0 minus 7 plus 45 is 38. And that is how you do it. Done. For this one, we're doing C times E. And the thing to note is we got 2 columns here in the first one, and then we got 3 rows. Those numbers don't match, and they have to match in order to even multiply these matrices. So this operation we cannot do. We cannot carry it out. So we will say our answer here is undefined. That's how you do it. Done. So for this one, we're meant to translate it back into a system of linear equations from the matrix. So the way you would do that is, this is x, this column is y's, this column is z's, these are coefficients, and then these are standalone constants. So the first one would be 1x plus 0y minus 3z is equal to 7. For this one, it's 0x plus 1y plus 2z equals -5. This one's all zeros, so we don't even have to write it out. Now, the question is there a unique solution or not? And the thing is, since we only have 2 equations with 3 variables, this is going to be an infinite solution situation, right? I can come up with infinite relationships between x and z. And just to give you an example, right, I could have one instance where x is 7, z is 0, and then y would be -5. That's one example. And then another example is I could make x be 28. I could make z be 7, right? That still works. 28 minus 21 is 7. And then y would be -19. This is just 2 different examples, right, that are viable. But again, I can come up with an infinite amount of these. So there will be infinite solutions. That's how you do it. Done. So for this one, they just want us to write the augmented matrix that relates to these 3 equations. So basically what you do is you take those 3 constants, 7, 0, and 3, and we put them over here. And then we put the coefficients in order for x, y, and z in that alphabetical order, like so. -2, 2, and 1, right? 1z. Then we got 2, -8, and 5z. And then we got 19, -10, and 22. And that is how you do it. Done. All right, so let's write out the augmented matrix for this one. Again, we got a triple system. So what we're going to do is we're going to put the coefficients over here for that equation, and then this constant right here. So we got 1x, we've got no y, so that's a 0. Then we got 3, and then equals 12. We got -1x, 4y, and no z, and then we got 0 over here. And then we got no x, we got a 1y, we got a 2z, and a -7. And that is how you do it. Done. For this one, we're going to solve by doing a little Gaussian elimination. The way we start that is by putting it in an augmented matrix where we got the x and y coefficients, 3 and -4, like so, and then that constant over here. And then we got -6 and 8, like so, here. And of course, we have to put that 6 here as well. Okay, the idea with Gaussian elimination in a 2x2 is we need to get the matrix looking like that nice identity of diagonals of 1s and 0s everywhere else. And then once we get it to that point, we're going to have x here and y here. Okay, and let's use our matrix operation. So we can, just like an equation, I can multiply the whole thing by a constant. I can divide it by the same constant. I can even add these rows together, etc. So let's start with this position. I always like to focus on the 1s first in each column. So I want to get that to a 1. So what I'm going to do is I'm going to multiply row 1 by 1/3 to get a new row 1. So we're going to rewrite it over here now, right? So we go boom like this. And then 1/3 times that is 1. 1/3 times -4 is -4/3. And of course, 1/3 times 1 is 1/3 as well. Cool. All right, so at least we got that. Now, let's flip that to a 0. I'm going to do that by doing 6 times row 1 plus row 2 to get a new row 2. Let's write it out. So we got 6 plus -6 is 0. Negative 24/3, which is -8, plus 8 is 0. Well, that's interesting. And then 6 times 1/3 is 2, plus 6 is 8. Okay, so now that we've kind of got this situation where we've got 0, 0 equals 8, let's think about that, right? That means 0x plus 0y equals 8. That doesn't make any sense. That's not a thing. So this is an indication that we've hit a wall and there's actually no solution. Now when we look back at these two equations, it actually makes sense that this is a no solution situation because these two lines are actually parallel. So check this out. If I multiply the top one by -2, I get -6 plus 8y equals -2. So you can see that, if we put in the slope-intercept form, both of these would have the same slopes but different y-intercepts, aka they are parallel, no points of intersection. So this is a no solution situation. Done. To solve this one with Gaussian elimination, we're going to first put it in that nice matrix, right? And we've got those coefficients 2, 3, 2, and a 1. Over here we got -4, -6, -4, and -2. And then we got 10, 15, 10, like so. And this is all equal to 0. Okay, now to carry out Gaussian elimination, what we have to do is we have to get this side over here with this nice diagonal of 1s, and then 0s all around like so. Okay, so let's begin and let's start by zeroing out these two right here. I'm going to start with that. Normally I'd like to flip that to a 1, but this is going to be nice and easy to zero those out. So I'm going to start with that and I'm going to do it in one step. So to zero this out, I'm going to do 2 times row 1 plus row 2 to get a new row 2. And then I'm going to do 5 negative times row 1 plus row 3 to get a new row 3. Let's write it out. So we got 4 plus -4 is 0. 6 plus -6 is 0. 4 plus -4 is 0. 2 plus -2 is 0. Very interesting. So what does that mean? That means that these first two equations are identical because they zeroed each other out. But we're going to come back to that. Next, we got -5 times 2 is -10 plus 10 is 0. Then we got -15, right? Because we do that times -5. -15 plus 15 is 0. -10 plus 10 is 0. And then we got -5 plus 0 is -5. All right, very interesting. So what we can see right off the bat is these two equations must be identical, right? And you can see that once again, multiply this by -2 and they're the same. But this one, it's like the same, probably the same coefficients multiplied by 5, but then the constant's different. Again, this is a situation where there's not going to be any intersection, not going to be any solution. So because of this triple zeros and then a constant, that doesn't make any sense, right? 0x plus 0y plus 0z, how can that equal -5? So that's your indication that this is a no solution situation. So no solution is the answer. Done. So for this one, to find the inverse, first we're going to write out the matrix like so. We're going to swap these two. So we got -0.4, -0.2 down here. And then these guys are going to be negated. So we got -1.2, -1.4. Okay. Then we're going to multiply this by 1 over this product minus that product. So -0.2 times -0.4 is +0.08 minus -1.2 times -1.4, which is +1.68. So as we simplify this, this is going to be 1 over -1.6 times this. And this is basically the final answer. But let me show you what they did, why they have a different answer in the back of the book. So what they basically did at this point is they multiplied everything in here by -5. But if you do that, you have to simultaneously divide this by -5, aka multiply it by -1/5. Okay, so that's how they reformatted it. So when you do that, what happens to this is if you multiply this by -1/5, it becomes 1/8. And then you multiply all these by -5, the reciprocal of -1/5. And the reason why we're doing that is because it kind of balances out, right? So that's why it doesn't change anything, but it reformats it. So then you have -5 times that, that's 2, -5 times that, that's 7, -5 times that, that's 6, and -5 times that is 1. So anyways, either answer is correct. That's how you do it. Done. To find the inverse of a 3 by 3, what we're going to do is we're going to first put down the matrix over here. And then we're going to put that nice identity matrix over here with those diagonals of 1s. and zeros everywhere else. And then what we're going to try and do is we're going to try and flip these to look like this, and simultaneously applying those operations over here. And then when we've got the identity matrix on the left side, whatever we have on the right side will be the inverse. So I always like to start off by flipping this position to 1. Now, again, I can divide everything by 12, but a really easy thing would be to just swap, right? If I swap row 1 and row 2, then I got a 1 there. Granted, it'll be negative, but we can deal with that afterwards. So let's rewrite that. So we got negative 1, 3, and 2 up top, and then we got 12, 9, and negative 6 down here. Okay, and then again, I want to negate this entire row. So I want to negate row 1 because I want that to be a positive one. So that becomes positive. These two become negative, and that 1 becomes negative. Okay, great. Now we can start to zero these guys out. So I'm going to do first negative 12 times row 1 plus row 2 to get a new row 2. And by the way, let's just combine it. I can also zero this one out by doing 4 times row 1 plus row 3 to get a new row 3. Let's write it out. So we got negative 12 plus 12 is 0. 36 plus 9 is 45. And then 24 plus negative 6 is 18. Positive 12 plus 0 is 12. And then these are just going to be 0 plus 1 is 1. 0 plus 0 is 0. Then down here, we got 4 plus negative 4 is 0. Negative 12 plus negative 3 is negative 15. Negative 8 plus 2 is negative 6. And then we got negative 4 plus 0 is negative 4. Then 0 plus 0 is 0. 0 plus 1 is 1. Great. Now let's move on to the second column. And I always like to start with that 1 first. So I want to turn that into a 1. In order to do that, I'm going to multiply by 1 over 45 times row 2. Let's write that out. So we got this times 0 is 0. This times that is 1. And this times 18 is 18 over 45, which reduces to 2 over 5. And then times 12 is 12 over 45, which would be 4 over 9, right? Divide top and bottom by 3. And this would be 12 over 45, which divide top and bottom by 3, it would be 4 over 15. And then times 1 is 1 over 45, times 0 is 0. Cool. Okay, now what we're going to do is we're going to flip this and this to 0. So I'm going to multiply row 2 by 3 and add it to row 1 to get a new row 1. I'll also do the same to row 3. but I'm going to multiply row 2 by 15, add it to row 3 to get a new row 3. Let's write it out. So we got 0 plus 1 is 1. 3 plus negative 3 is 0. 6 fifths plus negative 2, which is negative 10 fifths, would be negative 4 fifths. And then we got 12 fifteenths plus negative 1, which would be negative 3 fifteenths or negative 1 fifth. And then 3 45ths plus 0 is just 3 45ths, or that is 1 15th. And then 0 plus 0 is 0. Okay, then over here we have 15 times 0 is plus 0 is 0. 15 plus negative 15 is 0. 15 times that's going to be, let's see, 30 over 5, which is 6, plus negative 6 is 0, okay? And then we got 15 times that is 4, plus that is 0. 15 times that is 15 over 45, which is 1/3, plus 0 is 1/3. And then 0 plus 1 is 1. Okay, we got to stop here because we got something weird going on, right? We got 0 plus 0 plus 0. We've zeroed everything out in this bottom row, but we've got values over here. This is going to be an issue. Right off the bat, when we see that we got 3 zeros in the mix, we can stop right here and we can say that no inverse exists, okay? No inverse for this one, and that's how you do it. Done. All right, so for these ones, we're going to solve these systems using the inverse. So let me show you how this is going to work. First, we're going to set up this matrix with those coefficients, right? So we got 0.3, negative 0.1, negative 0.1, and 0.3, right, for the x's and the y's. Then what we're going to do to get the inverse is I'm going to swap these guys, but they're the same, so it stays as is. And then these two are going to be negated, so they're going to become positive. And then I multiply it by 1 over a times d, which is going to be 0.09 minus b times c, which is negative 0.1 times negative 0.1, which is 0.01. Okay, and this is going to be 1 over 0.08 times this entire matrix, which is 0.3, 0.1, 0.1, 0.3. Okay, so this will give us our inverse. Now, 1 over 0.08, that's the same as 100 divided by 8, which is actually 12.5. So I'm going to replace this with 12.5. And then we're going to distribute in boom, 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 boom. Just good old-fashioned scalar multiplication. So this times this is 3.75 times 0.1 is 1.25. Again, same here. And then down here is again 3.75. Now that we have the inverse, we take that and we multiply it against those values, right? Those are the constants of each of those equations. So we got negative 10 and 14. All right, now for the final matrix, what we do is we multiply this by this plus this times that. So that's 3.75 times negative 10 is negative 37.5 plus 14 times 1.25, which is 17.5. And then we go this times this plus this times this. So that's again negative 12.5 plus 52.5, all right? And what does this simplify to for our final little matrix here? That's going to add together and give us negative 20. That's going to add together and give us 40. And this is my x value, this is my y value, which means I can state my final solution in coordinate form as negative 20 for x, 40 for y. That's how you do it. Done. So for this one, we have a 3 by 3 matrix that we need to set up. And again, we're going to use this, we use that inverse method. So first, let's get the matrix in here. We got 4, 3, negative 3, right? Just these coefficients. And we got 5, negative 4, and negative 1. Here, there's a 1 in front of the x invisible. There is no y, so that's 0. And then z will be a 1 again. Then we put that nice identity matrix over here. And what we're going to do to get the inverse is we make everything here look like this. And then what's left on this side is going to be the inverse matrix. And then we're going to finally multiply it against those at the top. Let's put those out here right now. We're going to multiply it against this matrix, which would be negative 4.3, negative 6.1, and negative 0.7. All right, let's begin. So I always like to start off with 1 in this position, which I can do by multiplying by 1/4. But an easier move is just to swap these two rows, right? Let's just swap row 1 and row 3. So let's write that out. So we got 1, 0, 1 up here, and then 4, 3, negative 3 down here. And notice how I didn't change this. I left that alone, and that's important. Okay, next, I'd love to flip this and this to zeros. So we can do that kind of in one nice step here. What I'm going to do is I'm going to multiply row 1 by negative 5, add it to row 2 to get a new row 2. And I'm also going to multiply it by negative 4 and add it to row 3. Again, I'm just saving space here by consolidating these steps. So first we have negative 5 plus 5 is 0, 0 plus negative 4 is negative 4, and negative 5 plus negative 1 is negative 6. Negative 5 plus 0 is negative 5. Then we have 0 plus 1 is 1, 0 plus 0 is 0. And then down here we have negative 4 plus 4 is 0, 0 plus 3 is 3, negative 4 plus negative 3 is negative 7, negative 4 plus 0 is negative 4, 0 plus 0 is 0, 0 plus 1 is 1. Great. Okay, we got that first column all done, right? We got the 1, 0, 0. Now we need 0, which is already done for us, which is amazing, but I need to flip that to a 1. So to do that, I'm going to multiply row 2 by negative 1/4. Let's write that out. So we got that times 0 is 0, times negative 4 is 1, times negative 6 is 6 over 4, which reduces to 3 over 2. Then times negative 5 is 5 over 4, times 1 is negative 1/4, and then times 0 is 0. Great. Now I need to flip this to a 0. This one's already a 0. That's nice. So let's write that out. I'm going to do negative 3 times row 2 plus row 3 to get a new row 3. So we got 0 plus 0 is 0, negative 3 plus 3 is 0, negative 9 halves, which is negative 4.5, plus negative 7 is negative 11.5. Then we got negative 15 over 4 plus negative 4, and negative 4 is negative 16 over 4. That's going to be negative 31 over 4. I know I'm mixing the fractions and the decimals, but it'll all resolve by the end. And then we got negative 3 times that is 3/4 plus 0 is 3/4. And then 0 plus 1 is 1. Okay, we're in a really good spot because we got column 1 and column 2 done. Now we need to do column 3. And again, I'm going to start by flipping that to a 1. So we're going to multiply row 3 by negative 1 over 11.5. Let's write it out. So we got that times 0 is 0, that times 0 is 0, that times that is 1, which is what we want. And then this times negative 31 over 4 is going to be positive 31 over 4 times 11.5 is 44 plus 2 is 46, okay? And then 3/4 times that is going to be, or negative, because that's negative, is going to be negative 3 over, again, 4 times that is 46. And then 1 times that is just negative 1 over 11.5. We can make it negative 2 over 23, just so we don't have the crazy decimals in the fractions. Now we got two more things that we have to zero out, this guy and this guy. We can do that in one move, right? So I'm going to do negative row 3 plus row 1 to get a new row 1. That's going to zero that out. And then negative 3/2 times row 3 plus row 2 to get a new row 2. All right, let's do it now. So first we have 0 plus 1 is 1, 0 plus 0 is 0, and then negative 1 plus 1 is 0. Okay, then we've got negative 31 over 46 plus 1, which is 46 over 46, gives us 15 over 46, all right? Then this negated plus 0 is just positive 3 over 46. And then this negated plus 0 is positive 2 over 23. Okay. And then for the middle one, now we've got negative 3/2 times 0 plus 0 is 0, times 0 plus 1 is 1, times 1 is negative 3/2 plus 3/2 is 0. Okay, now the fun fractions, here we go, negative 3/2 times that's negative 93 over 92, plus 5 over 4, which if I multiply top and bottom by 23, I get plus 115 over 92, which is going to be 22 over 92, or 11 over 46. Then we got this times negative 3 over 46, so it's going to be positive 9 over 92, and then plus negative 1/4, which is negative 23 over 92. Negative 23 plus 9 is negative 14 over 92, or negative 7 over 46, just reducing it a little bit. And then last but not least, we got negative 3/2 times that, which is going to be positive 6 over 46, plus 0 is 6 over 46, or if I reduce it, 3 over 23. Okay, here's our inverse matrix. It doesn't look so nice, but it is what it is, and now we have to take that and we have to multiply it against this guy. Now, one thing to remember, though, is we did swap row 1 and row 3, and I should have mentioned right off the bat, we need to swap these two values as well. So negative 4.3 then goes to the bottom, right? And negative 0.7 goes to the top. Very important. Okay, let's bring it down. Let's write it out. So here's the setup, and we're going to write it out, okay, in terms of we're going to color code how the multiplication is going to go. But I'm going to do it in a calculator because these numbers are pretty crazy. So it's this times this plus this times this plus this times this, and that sum is going to go here, and that's going to be my x value. Then we got this times this plus this times this plus this times this. That's going to go here. That's going to be my y value. And last but not least, we got this times this plus this times this plus this times this, and that's going to go here. So you can see we did the first multiplication and addition, and we get negative 1 for x. Now for the second multiplication, when we put it in addition, we get 0.2. So there's our 0.2, and now let's do the purples. And now for the final row, when you put it all in, we get 0.3. And so there it is, x, y, and z. So our final solution is negative 1, 0.2, 0.3. That's how you do it. Done. Students were asked to bring their favorite fruit to class. 90% of the fruits consisted of banana, apple, and oranges. So let's right off the bat say banana, apple, oranges, and we're going to just arbitrarily assign x, y, and z, okay? It said if the oranges were half, and by the way, these are each going to represent percentages, right? What are the percentages of each individual fruit? So it says that these three added together consist of 90%. So if we're talking about whole number percents, we can just have our first equation, x plus y plus z, and that equals 90. Okay, great. Then we're going to go to this next thing. It said, if oranges were half as popular as bananas. So oranges are half as popular as bananas. And it also says apples, which is y, were, that's equal to, 5% more popular than bananas. Okay, so check it out. We got our system. We got 3 equations and 3 variables. So this is great. Now, here's the dealio, right? We can solve this using inverses. We can solve this using a number of methods, but it didn't say how to solve it. And to be honest, we got a pretty nice setup to solve with a little substitution. So I'm going to roll with that. Now here we have y equals x plus 5. That's a nice two-variable equation, y and x. I'd love to get another two-variable equation with just y and x, and I can do that right here because it's saying that z is equal to 1/2 x. So watch this. I can do a little substitution, and then I got x plus y plus 1/2 x equals 90, right? And then these guys can combine to 1.5x. And here, so I'll write that out, or I'll write out as 3/2 x plus y equal to 90. And then if I just want to get rid of that fraction, just to make everything a little easier, I'm going to multiply everything by 2. We get 3x plus 2y equals 180. All right. Now to solve this system, I can use elimination, aka addition, or substitution. I'm going to use elimination. So check this out. First, I'm going to move this x over here. So we got negative x plus y is equal to 5, right? Subtracting x from both sides. Now, if we want to use elimination, I can multiply this equation by 3, and I get negative 3x plus 3y equals 15. And then just write this one as is. 3x plus 2y equals 180. And then now watch this. I can add these together. Goodbye x's. I get 5y equals 180 plus 15, which is 195. Divide both sides by 5, and we get y is equal to 39, right? 5 times 39 is 150 plus 45, takes us back there. Okay, great. So if I know that y is 39, aka apples is 39%, I know that x therefore must be 34, because 34 plus 5 is 39. So x is 34, bananas are 34%. And then last but not least, we get to oranges, which is z. And oranges are just half of what x is, half of bananas. Half of 34 is going to be 17. So oranges is going to be 17%. That's it. That's how you do it. Done. So for this one, we're meant to find the determinant, and we're going to do that in a 2 by 2. So the way you do that is you go this times this minus this times that. So it's 100 times 0 minus 0 times 0. That's just 0 minus 0, which is 0. That's it. That's how you do it. Done. To get the determinant of a 3 by 3, we start by rewriting it and then repeating column 1 and column 2 over here. So negative 1, 0, 0, 4, 2, 0. And then we're going to do a little multiplication and addition. So first, I'm going to take the product, add that product, and add that product. So all those products we're adding. And then we're coming back the other way with that product, but everything in red we're subtracting. So minus that, and minus that. Okay, so using the color coding, we got negative 1 times 2 times negative 3, which is positive 6, plus 4 times 3 times 0, which is 0, plus 3 times 0, which is 0. Now coming back the other way, we got 4 times 0 times negative 3, which is 0, negative 1 times 3 times 0, which is 0, and then 3 times 2 times 0, which is 0. So, you can see when there's a 0 in the mix, it just zeroes out. So when you combine everything, we just get a nice 6 for the determinant. That's how you do it. Done. So for this one, to use Kramer's rule, we've got to find the determinant of the main matrix with those coefficients. We got to find dx and dy. So I'm going to show you how to do that. First, let's find the main determinant. So we got 4, negative 2, negative 5, and negative 10. So again, we multiply. 4 times negative 10 is negative 40 minus negative 5 times negative 2, which is 10. And that gives us a determinant value of negative 50. So let's put that over here. Next, to do dx, okay, the determinant with respect to x. So what we're going to do is now we keep the y values as is, and then we replace the x coefficients with these constants over here, 23 and negative 35, and do the same thing. So we're going to calculate the determinant by multiplying that. That's negative 230 minus this product, which is positive 70. And that's going to be negative 300. So that is dx. And last but not least, we need dy. Okay, so it's the same idea. Now we keep the x coefficients as is, 4 and negative 5. And we replace these two with 23 and negative 35. And calculate the determinant, multiply those. 4 times negative 35 is negative 140 minus negative 5 times 23, which is negative 115. So That's negative 140 plus 115, which is negative 25. So that's d, negative 25. All right, or dy. So now to get x, okay, I do the dx divided by d, negative 300 divided by negative 50, which is 6. And then dy divided by d for y, negative 25 over negative 50 is positive 1/2. And that is how you do it. Done. So for this one, using Kramer's rule, once again, we're going to set up the matrices to calculate the determinants, and we need d, dx, and dy. So I'm going to show you how to do that now. First, to get the main determinant, we're going to put in these coefficients into the matrix. So negative 0.5, 0.1, negative 0.25, and 0.05, okay? And then we take that product, negative 0.5 times 0.05, which is negative 0.025 minus negative 0.25 times 0.1, which is also negative 0.025. Okay, so notice what's going to happen here. We're going to add these together, and we get a determinant of 0. So when you get a determinant of 0, okay, there could be one of two things happening. We could have a no solution situation or an infinite solution situation. So now let's look back at these two equations, right? They're either exactly identical, meaning infinite, or they're like parallel and they never intersect. So the quick way to figure that out is, watch this. If I multiply this bottom equation by 2, we can match up these coefficients, then we'll see what happens here. Well, I'll get negative 0.5x plus 0.1y is equal to, that times 2 is 0.3. Well, look at that. They are the exact same equation, which means there's going to be infinite solutions. So we can kind of tap out here. And all we need is a relationship between the x and the y values. So if I know that x is x, right? What is y relative to x? Well, first let's multiply this equation by 10 and we get negative 5x plus y. That's why I multiplied it by 10 to get a y equals 3. And then I add 5x to both sides and I get 5x plus 3 is equal to y. So my solution set therefore is x, comma, 5x plus 3. And that is how you do it. Done. So for this one, we're going to solve using Kramer's rule. So what I'm going to do is I'm going to first rewrite this matrix, the main one. And to start this off, to calculate the main determinant, right, we need d, dx, dy, and dz. So we're just going to make some room for all those. We need to repeat column 1 and column 2 first and foremost. So 4, 7, 1, negative 3, negative 9, negative 5. And then what we're going to do is we're going to take the product plus the product plus the product of those minus that product minus that product minus that product. So let's write it out here. So we got 4 times negative 9 times negative 5. That's 180 plus negative 3 times negative 3 times 1 is 9 plus 5 times negative 5 is negative 25 times 7 is 140, 35, 175, negative 175. Now let's do the reds. So we got negative 3 times negative 5 is 15 times 7, 70, 35, 105, but that's minusing 105. Then we got 4 times negative 5 is negative. I'm just doing it out of order because it's easier mentally like that, right? So negative 20 times negative 3 is 60. Again, we're minusing that. And then 5 times 1 times negative 9 is negative 45, but we're minusing that as well. This double negative turns into a plus. And now we can combine everything for D. We got 189 minus 75 is 14. And then we minus 165 plus 45. First, let's add 45. That's going to give us 59. And then we're minusing 165. And that's going to give us a value of negative 106 for the main determinant. Cool. Okay. Now we need to get dx. So the way we're going to get dx is we're going to keep this matrix, but we're going to replace the x column with these values. Once again, we're going to repeat column 1 and column 2 over here. And then we're going to multiply plus multiply plus multiply. Like those three products are going to be added together. And then we're going to minus that product, minus that product, minus that product. Okay, let's write it out. So we got negative 5 over 2 times negative 5, which is 25 over 2 times 9, which would be 225 over 2 negative. And then we got negative 3 times 5, which is 45 positive over 2. And then 5 times negative 5 times 3 halves is negative 75 over 2. Okay, now let's do the reds. So we got negative 3 times negative 5 is 15 times 3 is 45 over 2, but that's negative. Then we got negative 5 times negative 3 is 15 times negative 5 is negative 75 over 2. But again, we're minusing that, so it's going to turn into a plus. And then last but not least, we got 5 times 5, which is 25, times negative 9, which is negative 225 over 2, but we're minusing that, so that's going to turn into a plus because of the double negative. But look at this. This is so strange, right? We got these are going to cancel out, these are going to cancel out, and these are going to cancel out, which means dx equals 0. Okay, so we got 0 here. Now let's do dy. Again, starting back with this matrix, but replacing the y column with these guys. Let's write it out. Again, let's repeat these first two columns. And now to do the calculation, we do product plus product plus product minus that product minus that product minus that product. So let's do the calculation. So we got 4 times 3 halves, which is 12 halves, which is 6 times negative 5 is negative 30, plus negative 5 halves times negative 3 is 15 halves, times 1 is just 15 over 2. And then 5 times 7 times 5, that's 25 times 7, which is 175 over 2. Now let's do the reds. So we come back the other way. We got 5 times 5 is negative, obviously, but that becomes positive. 25 times 7 is 175 over 2. But again, this is the red, so we're minusing that. And then we got 4 times negative 3, which is negative 12, times 5 over 2, that's negative 30. But we're minusing that, so that is a double negative, becomes a plus. And then 5 times 3 times 1 is 15 over 2. But again, we're minusing that. Once again, look at this. We got goodbye, those cancel out, goodbye, those cancel out, goodbye, those cancel out, which means we have 0 for the determinant of y. And last but not least, we need to do the determinant for z. So again, we start with this, but then we replace this column with these guys. Let's write that out. So now we got this written out. Again, repeat column 1 and column 2. And then to do the calculation, we're going to take the product plus the product plus the product, and then minus this product minus this product minus this product. Okay, let's write it out. 4 times 5 halves is 20 halves, which is 10 times negative 9 is negative 90. Negative 3 times 3 halves is negative 9 halves, times 1 is just that, so minus 9 halves. And then we got negative 5 halves times negative 5 is 25 halves, times 7 is positive 175 over 2. Now we got the reds, negative 3 times 7 times 5 halves, that is negative 15 times 7, which is negative 105 over 2. But again, that's minus, so we're switching that to a plus. Then we got 4 times 3, which is 12 over 2, which is 6 times negative 5 is negative 30. But again, we're minusing that, so that becomes a plus. And then we got negative 5 halves times negative 9, 45 over 2, times 1 is just that, but we're minusing it, so minus 45 over 2. Okay, now let's combine all of this. 175 plus 105 is 280 over 2, which simplifies to 140. And then we got negative 45 over 2 plus negative 9 over 2 is negative 54 over 2, which is negative 27. And then we got 30 plus negative 90 is negative 60. So then we got negative 87 plus 140 is, what is that, 53, right? So dz is 53. So now that we have all of these, we can calculate the final values, right? To get x, we do dx divided by d, 0 divided by that is just 0. To get y, we do dy divided by d, 0 divided by that is 0. And last but not least, to get z, we do dz divided by d. 53 over negative 106 is negative 1/2. And that is how you do it. Done. I hope you guys enjoyed this video, and if you did, please click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.